Hey everybody, this is your 5-3 exponential functions video. So when you think of exponential, you may think exponent, which is right, but in this case, that would just be a polynomial if it had like one or more terms. If it only had one term, then it'd be monomial. So x cubed plus 2x squared, etc. would be a polynomial. Now, when we talk about exponential, that means that the variable is the exponent, like 2 to the x, 10 to the x, 1/2 to the x, etc. So these are exponential. So again, we want to evaluate and graph the exponential functions. Define what e is. So that's about 2.718, but we want to talk about it. So one thing we can say is if you go to the regular calculate screen and you go to the e button, it may want you to put an exponent. And if you're just trying to find out what is e, then put e to the first. Oh, I should have put it as a decimal. So there's your 2.718 and so forth. The other place where you may use e sometimes is in a document. If you go to the graph, press e. In this case, I want e to the x, and so it's going to look like that. So as you can see, the domain will be all real numbers, but the range would be from 0 up, but it's not actually using 0 since that's a horizontal asymptote. So you either do e to the first from the calculate screen or e to the x from the graph. So your rules are going to be the same as far as the exponents. If it's a to the s times a to the t, it's a to the s plus t. So the saying is, if you have like bases, you add the exponents. So if you have a squared times a to the third, that means a to the 2 plus 3. So that's a to the fifth. Now in this one, a power to a power, multiply the power. So a squared cubed is a to the 2 times 3, which is a to the 6th. The reason is because we think of that as a squared times a squared times a squared. So there are 3 of them. And then about this, you can split your terms and both have the same exponent. So if you have a b to the 4th, that means a to the 4th, b to the 4th. And then 1 to any power is 1. And if you have a negative power, then it's 1 over that. So a to the negative 2 equal 1 over a squared. Now another form of it you may see is, what if it's 1 over a to the negative 3? Then that would just be a to the third because it moves. A long time ago they used to say the minus is an elevator ticket to the next floor or to the bottom floor. So you either go up or down based on what you want to do. And then if it's anything to the 0 power, it's 1. So like 5 to the 0, negative 1,000 to the 0, that'd be 1. Now with the capital C, that just means you have a leading coefficient, which is called your initial value. And here they're talking about the graph and having your ratio of your common terms, your common consecutive outputs. So when it's linear, then you're going to have a common difference. That's like if you have a regular table, let's just say 0, 2, 4, and 5, 10, 15. You notice these are changing by 5, these are changing by 2s, so your slope would be 5 halves. So that's linear. Exponential would be, as an example, 0, 0, 1, 2, 2, 4, 3, 8, 4, 16. Because what I'm demonstrating is 2 to the x. Okay, so this difference is 2. This difference is 2, but this difference is 4. And this difference was 8. So you can say from here to here is 2 squared, from here to here is 2 cubed. Etc. Now one of the main things is your original ordered pair is going to be 0, 1 if you have no number in front. Like in other words, if you have 2 to the x, then this part right here is understood to be 0. That means 0, 1. But if you have 5 times 2 to the x, that'd be 0, 5. And on both of those, the base is 2. And then we're going to talk about end behavior, what happens far to the right or far to the left. So when it's positive or negative infinity. So here's your properties. The domain is all reals. There are no x-intercepts because there's a horizontal asymptote at y equals 0, which is, I guess, what they listed here. And then the y-intercept is 1, which means 0, 1. It is increasing because the left side of this graph is low and the right side is high, so it goes up. And then these are your 3 points, 0, 1, 1a, and negative 1, 1 over a. So, for example, if it's 2 to the x, it's going to go through 0, 1, it's going to go through 1, 2, and it's going to go through negative 1, 1 half. And you can compare that to what you were expecting. 2 raised to the x, Control T. There's your 1, 2, and your 0, 1. And there's your negative 1 with 0.5. You remember you can do Control T for the table, or use the menu item. Those were the properties. If I go back, these were the properties when a is bigger than 1, which is kind of like a vertical stretch. This is when it's between 0 and 1, like a vertical compression or shrink. So you're still going to have domain all reals and no x-intercepts, and the y-intercept's 1. Let's compare this. So if I say 0.5 to the x, it's going to just be reversed. So your domain is still all real numbers, but this time it's a decreasing function. So that's one of the main things. It's decreasing. And your points are going to be like this. Then we're going to do some transformations. We'll just show that on problems with adding or subtracting or moving it left or right. Now, it is an irrational number. E is irrational, kind of like pi, because it's 3.14, so on. Some of y'all probably know 3.14, 159, and even more, where you can think it's 22/7 approximately. So when you think E, think 2.7, and when you think pi, think approximately 3 as a whole number, or all those other approximations. Now there are parts where you're going to have to solve equations where you have to get the base the same. For example, if you have 4 to the x equal 8 to the x minus 3, I should put plus, x plus 3. I'm just kind of making up the problem here. The main thing is you can't just set your exponents equal until you have a like base. So this would have to be 2 to the 2x, and this would have to be 2 to the third power, and then do your thing like that. So then you'd have 2x equal 3x plus 9, and then say x is negative 9, because you move this over and move that over. So if you want to check that, 4 to the negative 9 equal 8 to the negative 9 plus 3. Let's see if that's actually true. 4 up arrow negative 9, and then 8 up arrow negative 6. And sure enough, we really did get the exact same decimal to several places. So you are going to have some problems like that. 2 cubed is 8, 2 squared is 4. You might have a 3 base, or a 4 base or 5 base. And we'll show an example where you have to graph it and get the intersection. Okay, so let's start with our problems. On the very first one, it's a definition. It's listed twice because it's multiple choice. So if you want to mark out the top, you can. A blank is in the form c a to the x. That's exponential. And the a is the growth factor because it's greater than 0. And the c is the initial value. So that means the y-intercept. Now on this one, it goes through these 3 points if a is greater than 0. Now on this one, it's just a calculator type question. What you're supposed to do is raise it to the power and round to 3 decimal places, and they're getting closer and closer to pi is approximately 3.14159, so forth. So these you just do e, well in this case 6 raised to the 3.14 power, and then you just round. And then what you might want to do is press up twice and then press 1 here. Whoops. 1 there. There you go. And so forth. Oops. Okay, so like that. So you're getting more and more accurate, because on the last one, they want 6 to the pi button. So you got to press the button to the left of the H and get it like that. Well, I got to press Control Enter. You get that. So 3775 makes it round to the 8. Now you just do e to the negative power, which means 1 over e to the 0.63. Okay, so we press the pi button, then we have a box, and there's the pi button, and there's the e. So this is one way to get e, and then put up arrow negative 0.63. That went in the wrong spot. Pi button, E, raised to the negative 0.63. So there's your answer. And they wanted you to round to 3 decimal places. Now again, if you didn't want to just press the pi button, you wanted to press the e to the x, then you could do it also. Now what if you just press this e? That may or may not work. I think it will. No, it didn't. So it sort of looks similar, but it's wrong. So what I'm trying to show you is you can use the pi button and go to E on the menu. You can use the E button to the left of 10 to the x, which has, what is that? Has ln on top of it for natural log. On top. But you cannot use the letter E. What I mean is you can't use the alphabet E. That did not work. Okay, so now we have some data, and it's going to ask, is it linear, is it exponential? So in this case, we're going to put our data in. You start by pressing List in Spreadsheet. New document, add list in spreadsheet. Label X and Y, and then enter your data. So you have X here, Y there, -1, 0, 1, 2, 3. Okay, so once your data is in here, what you're probably used to is linear regression. Menu, stat calc. And then there's linear regression. And when we do that with number 3, put your X, put your Y. When I do that, I get R equal 0.97, which is not perfect, not perfectly linear. It would have to be 1 or -1. And when I go to menu, 4 for stat, 1 for stat calc. Then you go over to exponential regression, which is A. So menu, 4, 1. This time I'm doing A, which is exponential regression. Then you put your X, put your Y. Oops, darn it. 416, press OK. Okay, this time I have an R value, which is a little bit closer. I see R squared equal 0.995. It's still not it's still not exactly 1. And so it'd be neither exponential nor linear. Now, if it actually were, because I guess I got to handle that case. Well, let me just do it here on the next problem. What you may want to do is reuse your table, and your functions will update. So in other words, if you don't go to a new document, but you just update your data, -1, 0, 1, 2. Now, if your table is longer, then you're going to get an error message, like I'm about to get one right there. It says dimension mismatch because my table, if the table is longer, get a dimension mismatch. But now I'm going to update this part. Oh shoot, I should have started higher, my bad. -1, 0, -1, 0, 1, 2, 3. Okay, so I actually do have the same number of table entries, but at least that's good for you to know. Sometimes they have more data points. Now, as I was typing that data, I noticed a pattern. 1 times 9 is 9. 9 times 9 is 81. and 81 times 9 is 729. And even if you go backwards 1, it's divide by 9. So if your table is longer, if you're overriding your data, you may get a dimension mismatch error. But notice when I did that, it updated this part, and R is only 0.76, which is not good at all. But when I went over to the exponential regression, oh, why did that not work? Oh, I hit quadratic regression. If you do menu 4, 1, A is exponential, put X and Y, then I actually see it. So when you do A is 1, B is 9, R squared is 1, that means for sure it's exponential. And the formula they have is A times B to the X, basically. So I'd say 1 times 9 to the X. But what we usually just do is write it as 9 to the X, because the 9 is understood. But if you do have a value other than 1, you'll need to put that in front. And then the B is the base. So like I'm multiplying by 9 every time, so that's why it's 9 to the X. So make sure you choose exponential if that's your problem. Now this one I can probably just do by hand, because I see 4, 4, 4, 4. So that's linear, and it's going to be slope of 4, because you're going up 4, right 1. And I know my y-intercept from this is 0, 4. So that's how you can do it by hand. If you'd rather just update your data, you can do that too. My x's are not changing, but my y's are. Whoops. There's the 4, 4, 1. With 4 as your slope, 4 is your B. R is exactly 1, which means it's linear, because we said linreg. What it didn't like is, well, on quadratic, it just has A to be 0, because it's a 0x squared. But what it didn't like is the exponential regression. So if you do linear and exponential regression on your table, we'll get error messages if it's not in the domain of the exponential. So you wouldn't get error messages in linear because it's all real numbers, but I'm getting all these errors in the exponential part. I mean, you can see that. So it didn't work out. There's my data. 0, 4, 8, 12, 16. Now also let's think one more little part about this. If it was exponential, it'd have to go through those certain points like we said earlier. Let's go back to that. Zero, 1, and 1A. And -1, 1 over A. So once we got to here and to here, it was going to not like the domain. But again, going back, this one does have 0, 1, and 1, 9, and -1, 1 over 9. Whoops, 0, 1, 1, 9. So that's your growth factor. Okay, I think those are all the table ones. I'm going to stop the video right there. Well, these actually look short. Never mind, I'm going to keep going. For this part, what you want to do is just graph the function and see which one matches. So you have to do F1 to all of these and see. Now, what you can notice is that the graph is upside down. The graph reflects the x-axis, so it's like y equal negative something because it's upside down. Remember what we said from before, if it's e to the x, it's supposed to be slanting up like that. That's e to the x. And so if it's like a negative in front of it, that's going to go down like that. So just go through your choices. Remember that if it's a negative exactly right there in the exponent, a negative exponent means flip the y-axis. So I'm going to do that. Put the negative sign there. And now it went like that. And that's kind of like what we wanted. The only other part was the base was 6 instead of e. So it's like that. Okay, so that's how you figure out your graph. Now on this one, what we do is we change it to have a like base. So we have 5 to the negative x equal 25, which is really 5 squared. Now that your bases are the same, you could say negative x equal 2, or just say x is negative 2. Now, on one like this, we already have a base of 5, which means you might want to, you could use your table when you have 5 to the x and look at the table. Because then you can figure out, is it really 5 squared, 5 cubed, 5 what? So 5 squared is 25, 5 cubed is 125. Now, if you don't like doing it this way where you can see all the values at one time, you probably could do a number of things. You could do, well, is it 5 squared? No. Is it 5 cubed? Yes. The other way you could do it is say 125 divide by 5 and then divide that by 5 and figure out that 5 to the third power, however you want to do it, is 125. So look at the table as one method. You could do whatever I said. You could try 5 squared, 5 cubed as the second method. Or you could do 125 divide by 5 and then divide by 5. So that's the third method. Doesn't really matter how you do it, as long as you figure out, what it should look like. But now that we know what that is, you'd say 5 to the 2x plus 1 equal 5 to the third. So basically we're replacing 125 with 5 to the third. That's substitution. So once your bases are equal, then you say 2x plus 1 equal 3, and then you want to subtract 1, so 2x is 2, and then x is 1. So that's that. Now, I just thought of some other way to do it, because it's pre-cal, but it's like algebra. There's more than one way to do it. Another way would be, say, do 5 to the 2 times 1 power. And so that's 5 to the third, which is what we want. And if you did 5 to the 2 times 2 plus 1, that'd be 5 to the fifth, which is way too big. And so you could guess and check. There really are lots of methods. So if you put a 1 in there, do 2 times 1 plus 1. Okay, moving on. This one, we know you have 3 to the first is 3. 3 to the 0 is 1. But 3 squared is 9. 3 cubed is 27. Now, because of that, we say 27, writing the problem, 27 is the same as 3 cubed. And I'm doing parentheses so we can write that as 9x. Now, 9 is the same thing as 3 squared. But this is where you really do need to be careful to use parentheses. So this would be 3 to the 2x plus 4. And you can see how this is going to work out. 9x equal 2x plus 4. And subtract 2x. 7x equal 4. So then x is 4/7. So I can see that being a problem for some people, or a mistake. It will be a problem. Now, you can answer the problem correctly without it being a mistake. Ha ha ha. Okay, now on this one, it's a little bit more complicated. There's going to be a hard way to do this one and probably an easy way. I know probably y'all are interested in the easy way. And so the easy way would be call the left side F1, call the right side F2, and then adjust your window really high. So that is going to be the easy way to do it. So 25 to the x times 5 to the x squared power. And then the other part is 625 squared. Now that is a huge number. Just as show me how big that is, if you go to your table, you can see that's huge. Go to the table on function 2, and I can see it's 390625. That is huge. So that will tell us how big we need our Y max. Even bigger. I'm just going to put a 5, and then I'm going to put a bunch of zeros. Okay, so I did 5, and then I did 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So that's how I did it, and then the window was perfect. But you can, take your time and do it. Then we want to do menu. Basically analyze and then intersect. So menu 6, intersect is 4. And then go on the left side, you got it at -4. Menu 6, 4, got it, and I get 2. So your Y values are that huge number, but we just want the X's. So this is where I wrote menu 6 for analyze, 4 for intersect, and I got -4 and 2. So that's your answer. Probably want to do the same thing here. I mean, there was a harder way to do it, but I don't think y'all are interested. I really could do it. Make it 5 to the 2x. Make this 5 to the x squared. Make this 5 to the 4th squared. So this would be 5 to the 2x cubed, and this would be 5 to the 8th. 2x cubed equal 8, x cubed equal 4. Okay, that looked right, but apparently I messed up. X times x is x squared. That looks right. 5 to the 4th squared. Yeah, that's what we wanted. X equal the cube root of 4. Somehow it didn't work out. Sorry about that. I don't know. That's why I was doing the easy way. Our bases are the same. I put it in this other format. I don't know. I hope that doesn't bother me too long. let's just not do it this way or algebraically. And this is a mistake at the moment. Okay, so let's just graph these. I think I just figured out my mistake. That's all right. I'm thinking, probably overthinking, overthinking it. Because if I have 5 squared here and 5 there, that's going to be 25. That's probably my mistake. So if 4x cubed is that number, no. Okay, never mind. Okay, sorry, I guess I wasted your time a little bit, but I was just trying to work through my answer. There's something simple I probably did wrong. Okay, so moving on this one, we're just going to want to graph it. So like I said one time, when in doubt, graph. Okay, so we were just graphing this one. E to the x squared and then e to the 13x times 1 over e to the 30th. Okay, so I'm going to go to the table, and they're going to intersect pretty quick. But, God, that's a big number. You know what? This time I'm not going to be exact. I'm just going to say, give me some zeros. I'm not going to even count. Okay, and that was too much. And so let me take away a 0. It's still too much. Take away a 0. Okay, I think I can see it right there. So then you do menu 6 for between here and here. Gives you 3 comma, and then the y value doesn't matter. So that's what you want. Now, you can see on this one, the answer which is given to you is showing me more than one answer. But in the window that we have, it's only showing 1. So it looks like we need to adjust it even more. Okay, those are both really small values that are nearly E, actually. They're nearly 2.72. So let me change this part of the window. It's probably just too low, too close to C. Okay, menu 6, 4 between here and here. Menu 6, 4. Oh, I needed to go over here. Between here and here. No intersection found. I'm going to reset my window. Okay, so what we'll do on this is just zoom out. I do not see anything crossing at 10, but when we look in the table, I see it. Oh, you know what? It's probably because it says e to some power. Oh, it's right there. E to the 43. So it says 2.688 e to the 43, which is absolutely huge. And then when I go to the right, it says the same thing. Times 10 to the 43. No. Okay, I guess I would just have to put 43 zeros, which that's a pain in the rear. Let's not do that. Just use the table for the right side. Okay, on this one, we have 8 to the negative x equal 15, and then what does 8 to the 2x equal? It looks like on this one we want to graph it. Eight to the negative x power, and then just 15. So it crossed up here, so I've got to make this like 20 or 25. Okay, right there. Menu 6, 4, between here and here. It tells you that answer. I'm going to have a hard time getting that as a fraction. Okay, so what we want to do on this one is work it algebraically, where you have 8 to the negative x equal to 15, which means 1 over 8 to the x equal 15. And that's really 15 over 1, and then we want to cross multiply. Okay, so I wrote out the steps from the view and example on this. It's a little weird. It's been a while since I did this problem. So what you first have is 8 to the negative x equal 15. And because it's a negative x, we have to make it as 1 over 8 to the x. And then I made this as 15 over 1 so we could cross multiply. Now when we do that, it's basically this number times that equal 1. And then we want to solve for a to the x, and then we get 1/15. So basically, if you want to go from this step to here, you can. Now we want 8 to the 2x, and so if you actually get to that step, it's actually going to be easy. You're going to say 8 to the 2x would then be 1/15 squared. And so then 1 over 15 squared is 1 over 225. Now, on this problem, it's a graph type problem, and they want you to find the function. So based on it going down, it reflected the x-axis. So it's minus, and we know the base from the y. So that's -8. And then x. So that's what you get for that one. And then it looks like 16 is your last one, yeah. On this one, you graph it also. It's a piecewise function with it, so you're doing a certain function to the left of 5 and the other to the right. And so you're just going to end up graphing it, and that should be very obvious based on like these numbers, because there's nothing unique happening at 5 here, here, or there. Now based on that, the domain is going to be all real numbers, which is your negative infinity to infinity. Your range has to do with the y values, and so your range is y greater than or equal to 1, which is the same as 1 infinity with a bracket. And then your intercept is going to be 0 and then whatever that is, basically. If you have a 5, it's a 5. If you have an 8, it's an 8. They do want an exact answer here. They don't want a decimal. Okay, hope that helps. Have a good one.